Question number 19 of chapter 10. Two long parallel wires going into the plane of the paper are separated by a distance r and carry a current I each in the same direction. Show that the magnitude of the magnetic field at point P equidistant from the wires and subtending angle theta from the plane containing the wire is B is equals to mu naught by pi I by r into sine 2 theta. This we have to prove what is the direction of the magnetic field. Okay, so for that we will draw the diagram. Diagram is very important in this question. So here we have to show the two wires which are going inside the paper like that. Okay, so we will draw like that two wires. Okay, these wires are going inside the paper. Okay, and the distance between these two wires is given by capital R. Okay, it is given in a question. Now here we have to find the magnetic field which is at point P. Suppose this is point P. This point P is equidistance from this and from this also. That, so let us think that this is small r and this is also small r. This is perpendicular to the plane of that wires. Okay, this wire carrying a current I, we will name it as a AB, and this wire CD also carries the current I. Okay, both carries the current I. Okay, so here we have to find the magnitude. Here it is given that the angle is theta. So there also the angle is theta, subtended angle theta. So if this is theta, then angle between these two, this is point P, keep in mind, this is point P. So the angle between these triangles, three angles addition is 180. So theta plus theta is what? 2 theta. So 180 minus 2 theta. This angle is 180 minus 2 theta. So we have to find the magnetic field. You know that the magnetic field at a point due to straight conductor or conductor is B at P due to wire AB is equals to mu naught by 4 pi 2I divided by small r. This is the formula. Actually mu naught by 2 pi I by r we can write like that, but we can multiply and divide by 2 here. Okay, now we have to find this small r, but small r is not needed because in our answer capital R is there. So we have to replace this small r by capital R. So how to do? Here we will draw a perpendicular from this to this. This is 90 degree. So if it is r, this is perpendicular bisector, so this is r by 2 and this is also r by 2. Now if we find the small r, we have to find the small r. So we can write this is theta, this is small r, this is r by 2. So we can take a cos theta. Okay, so here we will do like that. Cos theta is equals to, what is cos theta? Adjacent side r by 2 divided by hypotenuse small r. So here we can write as a small r is equals to r by 2 divided by cos theta. Okay, or you can write like that, small r is equals to r by 2 cos theta. Okay, so here we will write like that. This is equal to mu naught by 4 pi 2I divided by r. In place of r we can write like that, capital R divided by 2 cos theta. Here we will write 2 cos theta. Division, it is in multiplication. Now this 2 2s are 4 and this 4 will get cancelled. So what is the magnetic field at point P due to wire AB? So see, magnetic field at point P due to the wire AB is equals to, what remains in that equation? So remains that mu naught I divided by pi r cos theta. Mu naught I divided by pi r into cos theta. Okay, this is the value of magnetic field due to the AB. Now if we see similar conditions are there, so magnetic field at CD at P due to the CD, that is also same mu naught I divided by pi r into cos theta, because all conditions are same. If you see that the distance from that wire AB is r and from CD also r, so that is same. This is angle theta, this is angle theta, so same conditions are there. So whatever magnetic field this applies here, same it will apply here also. Okay, now if we have to find the direction, so magnetic field due to this is current, this is r, so this is perpendicular to both, so we can take a perpendicular to this is magnetic field at P due to the wire AB, and from this we can draw perpendicular to this is the magnetic field at P due to the wire CD. Okay, so this is the direction, this is perpendicular to this and this is perpendicular. Now if you see, angle between these two small r is 180 minus 2 theta, means perpendicular to them is also having angle 180 minus 2 theta. Now by parallelogram law, a resultant magnetic field which is like that, if we complete its parallelogram like that, okay, so this will give us a resultant magnetic field. Okay, so this resultant magnetic field we have to find, so we will say that resultant magnetic field B at P is equal to under root magnetic field at P due to the AB its square plus magnetic field at P due to CD its square plus magnetic field at P due to AB into magnetic field at P due to CD into cos theta. Okay, here it is 2 also there. Okay, now this is equals to under root. If we know that these all magnetic fields are equal, so we will write like that: BP at AB plus magnetic field at P due to AB only in place of CD plus 2 times of here 2 times of magnetic field at P due to AB, its square remains AB, and this time 2 times it is, so it's a square, and cos angle between them is 180 minus 2 theta. Okay, like that. Now it is equals to under root, we can write as 2 times of magnetic field at P due to AB its square, this and this addition, plus 2 times of magnetic field at P its square and cos 180 minus 2 theta, it will give us a minus. Okay, it is here will we write minus minus cos 2 theta. Okay, now if we took what we will take common, it is 2 times of magnetic field at P its square due to AB in bracket 1 minus 2 cos 2 theta, sorry 1 minus cos theta only. Okay, now it is equals to under root here 2 as it is, this is magnetic field at P, and 1 minus cos 2 theta, it can be given as, it can be written as 2 into sine square theta. Okay, so 2 into sine square theta. Okay, so 2 to the 4, its square root is 2, BP due to the AB square root cancel and it remains sine theta. Okay, now this is the resultant magnetic field. Now we know that the 2 in place of BP we can write the value of BP, that is mu naught I divided by pi r into cos theta, and this is sine theta. Now you know that 2 sine theta into cos theta is sine 2 theta, so this is resultant magnetic field mu naught I divided by pi r into sine 2 theta. This is the magnetic field which we have to prove. So same derivation is there, mu naught by pi I r sine 2 theta.